All right, hello. This is week 10, the assignment sheet, question 8. So, um, I'm going to read this question slowly. So, if you do want me to just get on with it and get on with solving the question, you can skip this part. But um, as you may know by now, questions like these, understanding the question itself is quite a big chunk of it. So, let me begin. A rocket is launched off a platform and lands on the ground a short time later. Cool, off of platform, so off of something, goes poof, it goes off, and then it hits the ground again later. The height of the rocket at any point, yes, there's a bit of a typo there, but that's all right. At any point in the flight can be calculated using the equation that. Cool. Now, so that being said, that's a negative parabola. That's a quadratic where the one with the squared, the t squared, the coefficient is negative. So we have a parabola that looks like that. Wherever the axis is, I mean, it doesn't really matter at this point. We don't know yet. But there it is, where h is the height of the rocket. So that'll be h. And t, this whole thing will be t. It'll be the number of seconds since takeoff. Cool. Find the length of time that the rocket was in the air before it hit the ground. So they want me to find out how long the rocket was in the air. So the rocket probably goes, and then it's gonna hit the ground again. So it's gonna stop. Oh, it's giving me a straight line for some reason, and then it's gonna go, and then fall down and boom. Now, if having drawn that height, second by second, it's gonna go up. The time is gonna go, but it's gonna slow down. It's gonna stop going up. It's gonna start going down. It's gonna start coming down faster and faster and faster, and then boom, it's gonna hit the ground. So that's when h is 0. That's when h is 0. That's right there. Right? And if this is the graph, I'm guessing that t there in whatever seconds is how long it was in the air. And when that moment hits, that moment right there is the time since takeoff that the rocket has come back to the ground. So it's going to start off low, and it's going to hit h equals 0, because that's where the ground is. Right. So this is just general. We haven't calculated anything. We are just understanding the question. We're reading the equation, and we're thinking about what this might look like. Cool. Now, let's put that away. Because I do want to work here where I can see the question. Let's begin. Now, find the length of time the rocket was in the air before it hits the ground. So when it hits the ground, h equals 0 when it hits the ground. Let's make my pen a bit thinner. I'm not going to be able to write much. Right? H equals 0 when it hits the ground. So let's figure that out. So let's say when this whole thing is 0. All right. Now, we can work with this. The coefficient of this term here is -1, because the t squared is multiplied by a -1. I know the 1 is invisible, but since it is negative, it's not exactly our simplest format where we can go into our two brackets immediately. However, because and we can work with this, and we can figure it out by doing some other steps, but I am just going to multiply both sides of the equation by -1. So 0 times -1 is just 0. This whole thing times -1 is flip the sign, and then flip the sign. Right? Cool. Now, remember, if we want to find out when h is 0 in this equation, We are just solving for this equation, right? We are solving. We're trying to find out the values for t. Because the values for t when h is 0 will be the 2 points in time since takeoff that the rocket will hit the ground. Or the rocket will be touching the ground. Cool, let's carry on. So I think about two numbers that multiply to -7, but add to 6. And you have a think about this. You obviously try it before me. Do try it. Do definitely try it. At every point, pause the video and you try the next step and see if you can get ahead of me every time. And then just watch a little bit by little bit to confirm that you are heading in the right direction. So I've got the two numbers. Let's have a try now. It is -7 and +1. Right? So we're saying either that is that is 0 or this is 0. So we have our two possible answers, t equals 7 or t equals -1. Right? Now again, this is just in our mind doodling kind of phase. If we have our axis here and we're drawing this graph, it seems to be that it seems to go right there at -1. It seems to go right there at 7. It doesn't seem to start here. It doesn't seem to go through here. Well, that makes sense because it doesn't actually start off. The rocket doesn't blast off from ground. It blasts off from some platform. So it must have been raised off of the ground to some point. I know this graph, my hand drawing, has been a bit exaggerated, but we do know that it will be off the ground where it begins. It'll blast off into the air. Then it will hit the ground at 7 seconds. So of course at -1 second, it wasn't actually on the ground at -1 second. Of course, the whole thing actually just begins at 0. That's just how the modeling works. Of course, for our little graph here, it only applies up to here. And of course, everything beyond this, larger than 7 and lower than 0 seconds, doesn't apply to us. This model doesn't apply anymore. But anyway, having figured that out, that's side talk, but back to our main question. Now, back to our main question, we know t cannot be, negative, so t equals 7 seconds. So we are saying that it hits the ground 7 seconds after it launched, which is precisely the question. Find the length of time that the rocket was in the air before it hit the ground. So it took off, and 7 seconds later, it hit the ground again. So there you have it. Right? So there was the assumption, or not the assumption, we have to make the substitution into the equation that h will be 0 when it hits the ground. So that's the first thing that we have to do. Then we have to solve the equation having put 0 in place of h. Right? Having done this, we solve this fellow along with the whole thing equaling 0. Right? So we're getting two solutions. Of course, one of them does not apply in our practical sense. Right? The mathematical model only applies for a certain range of values, doesn't apply for negative values. So it was in the air 7 seconds. Because we know at 7 what that means is at t equals 7, h was 0. Which means it hit the ground. So there you go. I went particularly slowly for this question just so that we know what was happening. This solving bit is just solving a quadratic, but of course we had to get here a bit of a different way than usual. So we had to read the question real carefully to understand what it's asking for. And yes, this is the bulk of the question, unfortunately. So I hope that wasn't too confusing. Please let me know if I've skimmed too fast through some of the explanations and you want me to elaborate any of these steps. do let me know. Otherwise, have a lovely day.